So today, quadratics with complex roots. So when you see the word complex, it means you might have things with i's in it, right? Imaginary. Imaginary means, that's what it means, complex. Roots. What is a root? Root is the same thing as a solution. So if we're getting a solution, how do we get a solution? By doing what? Solving. Yeah, so we're solving. So if it says find the roots, it's a fancy way of saying solve. Okay? Because some of these questions, it says, what are the roots? And you're like, I've never seen that before. It's the same thing as solve. We've done that before. Okay? Because roots are the same thing as solutions, all of that good stuff. Okay, so these steps, 1 through 4, we can use those steps anytime we're solving. Sometimes they work, sometimes they don't. If they don't work, we have to use the quadratic formula. Okay, so the same thing. So we're not using any new steps. There's no new steps I'm showing you today. But sometimes we have situations where we have complex imaginary stuff. Okay, so it's not anything. The steps that we're doing today, not anything you guys haven't done. Okay, so let's look at example number 1. What are the roots? Okay, so roots, same thing as solutions. So roots means solve. So we have to solve the equation. Okay. Okay, so we have solving. Same steps as we've done before, right? So first step is make sure this is in standard form. Make sure it's equal to 0. It's equal to 0. It's in standard form. Step 1 done. They already did step 1 for us. Sometimes they'll do that, sometimes they won't. Step 2, GCF. Does this guy have a GCF? Besides 1? No. So skip that step. Okay. Next step was ABC. Okay. So ABC. So A equals, B equals, C equals, right? A is 1. B is -6. C is +45. So 1 times 45 is 45. B is -6. So I have to find the two numbers that multiply to be 45 and add up to be -6. Okay, so let me make a list of all the numbers that multiply to be 45. 9 times 5. 15 times 3. 45 times 1. None of those add up to be -6. But I also have negatives. -9 times -5. -15 times -3. -45 times -1. Do any of those add up to be -6? No. So when we run into a case like that, where we can't use this, there's no two numbers there, right? They don't exist. We have to use that's when we have to use the quadratic formula. Okay, that's the tool we have when we can't use it. Okay, so I'm going to plug in A, B, and C where they belong, just like we did last week. -1, parentheses, plus or minus, square root, parentheses squared, -4, parentheses, 2 parentheses. Just like I did last week, right? I'm going to plug in A's where A's go. A's go inside right there. A's go here. B's go there, and C goes there. Okay. A, here and here. B, here and here. C, there. Okay. And then last week, we just literally plugged that into the calculator, right? That's what we're going to do. We're going to plug this into the calculator and see what happens. Okay, just like I did last week. So I'm going to go. So -1 parentheses, -6. We can't do plus or minus, right? So we'll just do plus first and then minus second. Okay, so we'll do plus first. Parentheses, -6 parentheses squared, because that was b. -4 parentheses, a was 1, c was 45. Over 2 times a. And we get something, we say undefined. When did we get undefined? We've gotten undefined before, right? We got it the other day. When did we get undefined in in the calculator? When we did what?
A negative in the square root.
Yeah, right. When I tried to do this, oops, the square root of -16, right? We got undefined. The reason the calculator is saying that is because that's what we have in here. When I simplify this inside underneath the root, I'm going to get a negative. I don't know if it's going to be 16, but it's going to be a negative. So that's the difference here. We can't just get our answer because there's a negative inside of here. So what are we going to do? We're going to do it by pieces. We're going to do little chunks at a time. Okay? We're going to do little chunks at a time because we can't do the whole thing all at once. Okay, so let's see. First thing I'm going to do, -1 times -6, +6. Plus or minus. Okay. -6 times -6, -6 squared, +36. Minus 4 times 1 times 45.
Where did the 4 come from?
Right there.
Oh, it's in the
It's always there, yeah. Mm-hmm. That guy's always there. Just like the 2 on the bottom, it's just always there. It's part of the formula, yeah. So 4 times 1 times 45. Let's go to my calculator for that. 4 times 1 times 45, 180. And then 2 times 1 is just 2. Okay. So now on the inside of the root, I got to go 36 minus 80. 36 minus 80 is a negative number. It's a negative 144. That's why my calculator couldn't do it. My calculator is not smart enough to do complex numbers. That's why they're called complex, right? We can do it because we know about I, right? They can't. The calculator can't do it. Okay, so anytime you have something with a complex negative under the root, imaginary, your calculator can't do that part. You have to do it for it. Well, what is the square root? We talked about this on Thursday. What is the square root of -144? 12i. Yeah, 12i. So we get 6 plus or minus 12i, all divided by 2. Yeah, my calculator can't do the I part, but I can. So now what I'm going to do is I'm going to simplify this. See how both of these guys, 6 and 12i, both have a 2 underneath? They're divided by 2. So I'm going to give them each a divided by 2 because they're both being divided by 2. I'm going to give them their own. Simplify. 6 divided by 2, 3. Plus or minus, 2 goes into 12, 6 times I. Here's my question now. How many answers do I have? Or first of all, can I add 3 and 6 together? No. Can I subtract them? No. Now, how many answers do I have? Yeah, I actually have 2 answers. I have 3 plus and 3 minus. So when I put it into Delta Math, you're going to use 2 boxes here. One for 3 plus 6i, and one for 3 minus 6i. Even though I can't subtract them, one needs a plus and one needs a minus. Okay. So I have 2 answers. They're both imaginary, right? How do I know they're both imaginary? Because they have eyes, right? They have eyes. So they're 2 imaginary roots. So we have 2 imaginary roots. Okay. It didn't ask that part, but it's going to help later when we get to those. We'll get to this part later, the types of roots. Okay. All right, so flip it over. Let's look at number 2. Same thing. What are the roots? So solve this guy here. Okay. Step 1. So I put the steps. The steps used to be up here. They're in your notes, but I moved them over here. Trinomials, since it's a trinomial. Step 1, set it equal to 0. This guy's not equal to 0, so I got to do that step. So I'm going to add 30x to both sides. So this side makes 0. Can I add 30 to 9 or add it to 29? No, because 9 has an x squared. Close, but not the same. 29 doesn't even have an x. So where am I going to put that 30? Right in the middle. Yep, right smack dab in the middle. There we go. In standard form, equal to 0. Step 1 done. Step 2, is there a GCF? Well, they're kind of big. So is there a GCF between 9, 30, and 29? I don't think so. Yeah, 3 goes into 9 and 30, but not 29. So no GCF. So ABC. Nine, 30, 29. So I got to multiply 9 times 29. Oops. $261. So A times C is 261. 9 times 29. B is 30. I don't know what goes into 261. Honestly, I could use my calculator, but some of you come to this point. Some of you have said, Mr. Flores, this is a big number. I don't know what goes in here. Here's the thing about the quadratic formula. It always works when it says solve. When it says solve, it always works. So let's say there are 2 numbers that multiply to be 261 and add to be 20. Let's say there are 2 numbers and I don't get them. And I go to the quadratic formula. It's okay. It's okay. When it says solve, that's okay. If it doesn't say solve, we can't do it that way. Okay? So let's go to the quadratic formula. -1 parentheses plus or minus square root parentheses squared minus 4 parentheses 2 parentheses. Plug in A's where A's go, plug in B's where B's go, plug in C's where C's go.
so B, whatever number is B goes in the first,
Yeah.
first and second parentheses.
Mm-hmm. Yeah, B is the first two parentheses. B is always going to be here and here. A is always going to be here and here, and then C only goes in once. Okay. Okay, so now let me go to my calculator, and let's hope that I don't run into the same situation I did last time. So 30, 30, 30, 9, 9, and 29. I do. I run into the same situation. So what do I have to do? I have to do it piece by piece like I did the last one. Doesn't mean we can't do it, but it just means I have to do it a little bit slower than I did last week. Last week I could just plug it in, boom, got my answer, right? Today I can't. I don't have that luxury because there's negatives. Flores. Okay, so let's do it piece by piece. Yep.
So what in your license, but it's always like has that -4, but it not always be on the final.
Not necessarily, no. Because if this number is big enough, it doesn't matter if you subtract because, yeah, so if B is big enough, it'll make it positive, but B is not big enough. Yeah, there will be some times when we plug in and we'll get positive answers. Yeah. This won't always happen. Like on your test, there will be some that this happens, and there will be some where you can use it. Okay, yeah, it just depends on what A, B, and C are. Okay, so -1 times 30 is -30. Plus or minus 30 to the second power is 900. Four times 9 is 36. 36 times 29, I believe, is 1,044. And then 2 times 9 is 18. Okay. Now I have to subtract. You can see right now that 900 minus 1,044 is going to be a negative number. That's why your calculator couldn't do it. So we get -30 plus or minus the square root of -144. It won't always be -144 in there. It'll be different numbers, but for these, it's for some reason it's always -144. Okay. I can do that part. What's the square root of -144? 12i. Give -30 a divided by 18 and give 12 a divided by 18. Okay. I got 1 plus, 1 minus. You notice how the negative in front doesn't change, though? That one stays. Only thing that changes is the sign in the middle. Reduce. What's the biggest thing I can that goes into 18 and 30? 6, right? So you divide that by 6, divide that by 6. You get -6/5. Same over here. 12 and 18, biggest thing that goes into 12 and 18 is 6 again. So you get 2/3 I. 2/3, yes.
first one, if you're dividing both of them by 6, it would be negative 5 over 3.
Yes, you're right. Yeah. No, yeah, you're right. I'm wrong. Yep. Change that for sure. Thank you. Yeah, so if you divide them both by 6, that's going to be 5 over 3. Yeah. No, for sure. There you go. So you have 2 answers, 2 boxes. Done. Negative 5/3 is the real part. 2/3 and negative 2/3 is the imaginary part. Okay. Yes.
How do you tell like what I do again? Like if it's like negative I.
Oh, sorry, up here?
Yeah.
So we know that the without the negative, right? Without the negative, what's the square root of 144? 12. Because of that negative, you throw in an I. So anytime you have a negative underneath the root, you're going to have an I. So like the negative 81 is positive 9, right? And then because we had a negative underneath 2, you have to throw an I. If it's just regular 81, you don't need it. So anytime you have a negative, you're going to have an I. That's where the I comes from. Yeah. Okay. All right. Okay. Do number 3 now. Do number 3. I'll give you 5, 6, 7 minutes to do that one, and then we'll go over it. Okay. So if you're still working on it, keep going. I'm just going to get started on it. So I did the first step. It's already equal to 0. It's already in standard form. Skip. No GCF. They're big numbers, 9, 54, and 85, but there is no GCF besides 1. You can divide 9 and 54 by 9, but 9 doesn't go in 85. So got some pretty big numbers. 600. So A times C, 765. Now, there might be 2 numbers that multiply to be 765 that add up to be 54. But again, when you're doing this, like let's say I have a test. Let's say this is next week, and I have this problem, and it's on a test. I'm not going to spend all my time trying to do that. If it says solve or find the roots, go right to the quadratic formula. That's a better use of your time, because I'll have students who will sit there for 20 minutes and try to do this, and they won't do other problems. At the end of the period, they're like, I didn't do these last 2 because I was trying to mess around with this one. Try for a little bit, but especially if the numbers are big. If they're super big and it says solve, just go right to quadratic. Okay? Because the quadratic formula, that's why the quadratic formula is there. It was created for situations like that. So we get -1 parentheses plus or minus b squared minus 4 times a times c over 2 times a. So I'm going to plug in my a's, b's, and c's. So I go to my calculator and hope that'll give me something good that I don't have to. So 54. I think it's still 9, 9, and 85. No, undefined. So I got to do it by pieces. So I'm going to do -1 times 54, which is -54. Plus or minus 54 to the second power, 54 times itself, 2,916. 4 times 9 times 85. $3,060. 3060. Then 2 times 9 is 18. $2,916 minus 3,060. You're going to get, again, negative 144. It's not always going to be negative 144. I don't like how on the notes they kept getting the same answer in there. You will get different numbers. Sometimes you'll get negative 81. Sometimes you'll get positive 81. Sometimes you'll get things like that. Okay? So if it's a negative, throw in an I. If it's not, you don't need to.
So like if it's not negative and you have like 3 plus 9, would you just add them together and only have one answer?
Yeah. No, we always get 2 answers because that plus and minus is always there.
Oh,
But yeah, so yeah, it won't have an I. Pretty much if it's positive, it won't have an I. If it's negative, it will have an I. That's the only difference. Yeah. Okay. So we get negative 54 plus or minus 12I over 18. Split them up. One gets the plus, one gets the minus. Negative 54 goes first, 18 goes under it, and then 12I and 18. Last step, if you can divide, divide. If you can reduce, reduce. 18 actually does go into 54 evenly. 18 times 3 makes negative 3. Sorry, it makes 54. So this is going to be negative 3. Twelve 18ths I can reduce. Divide them both by 6. Oh, thanks. One answer here, one answer here. You'll know you did it right if both of them are exactly the same except one key difference. One has a plus in between, one has a minus in between. Oops, forgot to put the I here. Okay. All right. One last thing will be done. One last thing. I'm not going to give you any extra problems. One last thing will be done. It's called, and it's something we've done before. It's called the discriminant. The discriminant. Discriminant means specific. Okay, not discriminate. It has nothing to do with the word discriminate. It's discriminant. Okay, so specific is a specific part. So up here, you notice how I put the part in orange? That's the discriminant. It's a specific part of the quadratic formula. It's important because it tells us one of 3 things. It tells us what type of answers we have. Are we going to have real answers? Real answers or calculator answers? Decimals, negatives, positives, whole numbers, fractions. Those are all real. All right? Are we going to have 2 different real answers? Are we going to have one answer that just repeats itself? Or are we going to have a negative or an imaginary? The ones we did in our notes today, all imaginary because they have eyes, right? Well, the discriminant will tell us what type of answers we get, okay? Because those are roots, right? Those are roots. This one doesn't have a root because it doesn't cross the x-axis, okay? So on the last 2 problems, I don't care what the answers are. I just want to know, will I have 2 real answers, 1 repeated answer, or no real answer because they're imaginary? How do I know that? Well, is the discriminant positive Is it 0 or is it negative? Right? This guy here, the discriminant was negative. So we got 2 imaginary answers. Same thing here. Negative under the root. Okay? So that's the only part I'm concerned about on the last 2. And then what's the difference between a rational number and an irrational number? A rational number means I can write it as a fraction. So you notice when you use the Desmos calculator, sometimes you'll get like, let's see, 12 divided by 18. Sometimes by the decimal, there will be like this button here. That means I can also write it as a fraction. That's a rational number. But a number like pi, that sucker continues and doesn't end. I can't write it. That button's not there. So that means it's irrational. Okay? If it never ends, or even this guy would never end too, but I know what the last number is going to be. Right? It's just repeating. Okay? That's what irrational and rational are. Okay, so can I write it as a fraction? Okay, so the discriminant. So I'm only concerned about the yellow or the orange part. That's all I need is the yellow part. I don't need the rest for this guy because they're just asking for the discriminant. So all I need is the the orange. I still need to know what A, B, and C are though. So I still got to do my steps. Okay? So for number 4, what is A, B, and C? What is A here? -1. What is B? +4, -2, right? But for this guy, instead of plugging him into the whole thing, I'm just going to plug him into the orange part over there. So parentheses squared -4 parentheses. Just the part underneath the square root. -1, -2, +4. That part you can put in your calculator because there's no more root. So 4 squared makes 16. 4 times -1 times -2 makes +8 because the negatives multiply, so you get +8. So you get 8. That's the discriminant. So let's go back up to the top. Which of the 3 categories does it fit into? Is it greater than 0, equal to 0, or less than 0? Greater than 0. So we're going to have 2 real roots. 2 real roots. How do I know if they're going to be, so the next thing is, how do I know if it's going to be rational or irrational? Well, the square root of 81, or sorry, the square root of 8, is that a rational number or irrational number? Let's see. That doesn't have a fraction there, right? That means it's irrational. So this guy here will have 2 real roots that are irrational. Because the square root of 8 is like 2.8284. Keeps going on and on forever and ever and ever and ever and ever. If this guy was like 16, what's the square root of 16? Can I write 4 as a fraction? Yeah, 4 over 1. That would be rational. This guy was 81, 64, 36, 100, numbers like that. That would be rational. But 8 is irrational. Sorry, the square root of 8 is irrational, not 8. All right, last one. Last one and we'll be done. Okay, so A, B, C. What's A, B, and C? Good. Plug it in. A is 2. 24. 72. 50 or 24 squared is, I believe, 576 minus 576, I believe. I believe they're both equal to 576. That part you could just put in your calculator. Mm-hmm.
So you multiply all three numbers?
Mm-hmm. 4 times A times C. All multiplication. And then you subtract. So how many? We're going to get 1 repeated root. 1 repeated root. Okay. So that means if I were to actually do this problem like I've been doing the other problems for the whole chapter, I'd get 2 answers, but they would both be exactly the same. They would both be exactly the same. So 1 answer that's just repeated. That's what it means. If I were to do this problem like all of the other problems, use A, B, C, do all that stuff that I've been doing. Okay, that's what it means. That's what it means. Okay. Mm-hmm.
On a test, will we need to figure out if it's irrational or rational?
You might. So what I say is just take this, use your calculator. Whatever answer you get, just take the square root of that. And then if it's a nice, pretty number like 81, rational. If it's not irrational. Yeah. Okay. Okay, so tape. Let me pass the tape out. This is the last taped in section for this chapter. Page 16, it'll go in there. Okay. Yep. Yeah.
I have a question.
Mm-hmm. Wait, let me turn off my mic real quick and then.